Hello everyone, I am Afia Babarchi from BLDA College of Engineering and Technology, Vijayapura. I am currently studying in the CSE AML branch. Welcome to this tutorial on the conversion of epsilon NFA to DFA. In this video, we will understand what an epsilon NFA is and why we convert it to a DFA, and we will learn the full conversion method with an example. An epsilon NFA is a non-deterministic finite automaton that allows a transition without reading any input symbol. These are called epsilon or epsilon moves. But DFA does not support epsilon moves. So to make the automaton fully deterministic and suitable for implementation, we convert an epsilon NFA into an equivalent DFA. Here are the steps we follow to convert an epsilon NFA to a DFA. First is find the epsilon closure for each state in epsilon NFA. Second, represent each DFA state as a set of epsilon NFA states. Third is for each input symbol, find transitions using epsilon closures. And fourth is identify final states if any DFA states includes an epsilon NFA final state. Let's understand these steps in details. In first step, we find the epsilon closure of each state. The epsilon closure includes these states itself and all state reachable from it using only epsilon moves. As you can see in the image, it's a example. If Q0 by taking the transition epsilon, it moves to Q1, and Q1 by taking epsilon transition, it moves to Q2. For these epsilon closures are Q0, Q1 and Q2, and epsilon closure for Q1 is Q1 and Q2, and epsilon closure for Q2 is equals to Q2. As I told you, the epsilon closure includes the state itself, so that's why epsilon closure of Q2 equals to Q2. Next is step 2. Each DFA state is a set of epsilon NFA state. For example, Q0, Q1 and Q2. The formula for the DFA transition is as below. Step 3. We mark the DFA final state. A DFA state become final if it contains any final state of the epsilon NFA. So if Q2 is a final state in the epsilon NFA, then any DFA state that includes the Q2 is also final state. Now let's understand this with an example. We have an epsilon NFA with the states Q0, Q1 and Q2, and the input symbol is A, B and C. The state is Q0 and final state is Q2. So the epsilon moves are from Q0 to Q1 and Q1 to Q2, as we already seen in exam image. So the epsilon closure for Q0 is Q0, Q1, Q2. Epsilon closure for Q1 is Q1, Q2, and epsilon closure of Q2 is equals to Q2. And the DFA transitions as below. And the final, since Q2 is included, these become the final states. The resulting DFA has no epsilon transitions. Each DFA state is simply a group of epsilon NFA states. This new DFA accepts the same language but work. Each DFA states represent a set of epsilon NFA states like Q0, Q1 and Q2. This is the DFA transition table for this example. This represents the input symbols and the represented DFA states, and the column represent the input. For example, Q0, Q1 and Q2, on taking the input symbol A, it moves to Q0, Q1, Q2 itself. And by taking the input symbol B, it goes to Q1 and Q2 states. And by taking the input symbol C, it goes to the Q2. And this is a transition state diagram. As you can see, Q0, Q1 and Q2 is one state, Q1 and Q2 is one state, and Q2 is a final state. But we take Q2, wherever Q2 is there, we take that state is also a final state, because in our epsilon NFA state diagram, the Q2 is a final state, and the transition which are not moves to anywhere, we moves in the rejection state. Based on the transition table, we build this transition state diagram. That's the complete today's tutorial on converting epsilon NFA to DFA. If you found this explanation helpful, please like the video, share it with your friends, and subscribe to the channel for more automata theory tutorial. Thank you so much for watching this. This is Afia signing off.